tonight we're going to be looking at sort of a general overview of OnShape, sort of a refresher from last semester, and go through some of the FRC specific things so it's easier to start actually making stuff in OnShape. If you have not had an account, like I already said, OnShape4FRC.com has a great getting started guide that walks you through how to make an account. For step 7, for people on Spectrum, there is a form to fill out that gives me your username so I can add you to the team. You don't have to have that done for tonight. It's fine if you don't. But ideally, you do that soon so then we can all be working on the same projects at the same time. But this helps you get the educational account for OnShape and get everything going. The second thing that this does that is very convenient is it shows you how to link the MKCad parts library. And this is one of the biggest reasons why OnShape can save a lot of time, is that there's a group of people involved with FRC, students and mentors, who maintain this thing called MKCad. It was originally started by the Milken Knights, which is an FRC team out in California, I believe. And now it's just it's a bigger group of mentors from a variety of teams and students, I believe, who maintain it, but they add all sorts of the part libraries and parts that the vendors make specifically for FRC and a lot of the common parts we use in FRC. And this is by far the quickest way to get it all added into your OnShape. There's no way for me to do it for you. You have to do it into the account you're logged into, but it's rather quick. You basically just click this link, and it brings up the list of all of the MKCad documents, and you just make a new label called MKCad or something like that, and then it's really easy to access them from OnShape. I'm going to show you how to do that in just a second. So this is what it brings up. It brings up all of these different documents, and you basically just have to select them all, which I believe you can do by, so if you just click on the top one, and then if you go all the way down to the bottom and shift click on the bottom one, it'll select all of them. And over here in this labels for the selected document box, if you click that, yours won't have this MKCad thing yet unless you've already done it. But you can basically just hit create new label, type in MKCad, and then for you would hit create. I already have an MKCad label, so I can't do it. But that would make them all tagged for you, and it makes it very easy to look through the official MKCad documents and pull out all the parts we need. So there's different configurable versaplanetaries. We talked about versaplanetaries last semester, how there's a bunch of different options. This makes it super easy to insert one because you can like choose all the options and insert the exact right motor gearbox combination. They have the entire 2020 playing field set up, so we could, like, if we make a robot for it, you could put the robot onto the playing field already, or if you just need to get like field dimensions, you can do that. Sprockets, chains, all sorts of different parts. A bunch of them are configurable, so if there's different options in a variety of ways you can make something, it'll adjust it for you, or you can have different options so you can adjust them. The entire kit of parts chassis, different gears and gearboxes, whole Swerve modules, which we're actually going to be looking at later tonight. A lot of the fasteners we use in FRC are here. There's a couple different ways to do fasteners. This is one way. Later on, we can see one of the others. Pneumatics parts, verse parts, a whole lot of things that just save you a lot of time because we don't have to go find the model for these and import them ourselves and like make sure we have the right ones. It's basically already done for us. We don't have to maintain it, and it just works, and it's all there, which is great. And it's super easy to insert into our models when we need to kind of build stuff virtually. We have a lot of the parts already modeled for us, and so we're only modeling the custom stuff that we actually make in our lab. Okay, so in MKCad, let me actually, I can make a, we have a sandbox document in our folder. This is where I've been playing around with different things. So this is an OnShape part studio. This is an OnShape assembly. So this was actually me doing some of the MKCAD stuff already, I will go recreate this actually real fast. So I can delete those parts out of here. So this is just a blank assembly now. So this is where we would put in any of those already created parts from MKCAD. And the way we would do that is we use this insert button and we come over to other documents. And once you have that label made, you get a whole label for MKCAD. If you don't use the label, if I just like searched MKCAD in here, it was like MKCAD motors because I want to pull in one of the motors we use. If you just search that in general, it'll search every public database in OnShape, which is a ton of stuff, but you can never know, you don't really know who made it or anything. So there's possibly the official one, this might be it, and then there's just dozens of copies of MKCAD motors that other people have just like made copies of their own. There might be other ones that don't even show up. There's random other motors. So it gets kind of hard to figure out exactly which one you're using all the time and which one you're referencing if you don't use that tag. So using the tags is a really good way to make sure you're using the right one. So if I want a motor, I just come and click on the tag. Now I know I'm using the correct one. I can click MKCAD motors. I can find whatever motor I want. Say we want to do something different. Say we want a Falcon. I had a Sim before. Maybe we want a Falcon. When you insert, if you move your mouse around, you can still zoom over here with the scroll wheel. If you middle click, you can move around the whole field, so you can kind of see the origin there. So I can put the motor wherever I want. If I don't have my mouse over there, you can see it kind of like snaps back to that center origin spot. So that origin is like the center of our virtual universe. And so whatever the first part I'm putting in, a lot of times you'll just, instead of actually clicking somewhere, you'll let it go to the origin and you'll just click the checkbox. And now I have my simplified Falcon motor and it is kind of already put in a spot. That doesn't mean I can't drag it around because once you put it in, it doesn't necessarily stay there. So it lets me like drag it around. It also inserted with this pneumatic fitting that we don't really need. So if we need to delete something, we can always just like click on it. And then if we either hit delete on our keyboard or right click and pull up the big context menu and we can hit delete here and that'll get rid of that. Now, if I don't want to be able to move my motor around, like I want it to be able to be fixed at that origin point, I can right click anywhere on the motor and you just come to fix. It makes this little icon in the feature tree, part tree, whatever you want to call this over here. And it tells me that it's fixed. So now if I try to click and drag, I can't move it. It displays a little icon telling me it's fixed. So now I have my motor in the middle of the universe and I can't move it anywhere. But I can come in and I can insert other things. So if I want to put a pinion gear, which the pinion is normally the gear that goes on the output shaft of the motor, right? So this motor is going to spin. Output shaft is here. We're going to find the pinion specifically for the Falcon. My guess, because I don't necessarily know, my guess is it's in MKCAD gears. That's where I assume it would be. If we search Falcon, it probably comes up. Yeah, so we have a 10-tooth Falcon pinion, 11, 12, 13, 14, 8, and 9. There's a couple other different ones. So we're just going to go ahead and use the 10-tooth. It's one of the ones that's pretty standard. And so in this case, I can click on it. And again, if I don't drag it into space, it's just going to put it in at the origin. But now that's like inside of the motor. That's not really where we want it. So I'm going to go ahead and drag it out and just kind of click it into space anywhere. Right mouse click. And then go ahead and click the green check mark. If you don't click the green check mark, if instead you hit the red X, it actually won't insert it. It'll remove it. But luckily, OnShape is kind of nice to you, and it lets you click this restore button because it knows you make that mistake a lot. Because you're like, oh, I clicked it there. It's in space. I must be done. I can click the red X, but then it'll actually take it off because you didn't like finish the insertion. So that restore button is helpful. Okay, so I have these two things. This I haven't fixed, I haven't done anything with, so it's just floating in space. If I click on it, I can move it around. But what we want to do is we want to be able to put this on to the spline of the motor. So we do that with by mating them together. So that's the most important thing you do in assemblies is you're telling OnShape how are the two parts related to each other. How are they connected? What distance away? Or like kind of what's aligned, what's not. And all of these buttons, this row of buttons up here, are all different types of mates. So there's a fastened mate, there's a revolute mate. Well, as we get more and more advanced, we'll learn what all of them are. The fastened mate's the most useful one. It basically says this thing is connected and can't rotate, spin, slide, or anything. They just stay together, which is basically what we want right now. So we're just going to click the fasten mate button. And for the people who have used SolidWorks, or you may have used other CAD programs before, this is definitely one of the places where OnShape differs from the other CAD packages, but it's one of the places where it's very, very convenient and very, very fast. So we want to tell it that this pinion is going to be at the center. We basically want to mate this axis of the pinion gear, kind of the center of it, and we're going to slide it on to this shaft. And we should be able to do that pretty easily. We can basically get it to select the center edge of this pinion. And I can click on that. So I have one mate connector, which is that like circle with the three arrows coming out of it, the green, red, and blue one. And then I can do the same thing somewhere else. So say I can click there, and you can see that it added that new mate connector kind of right in the center above this face. And I can click on that one, and now it moved that gear into place. Except now those two mate connectors are touching, and it's a little bit too close, right? In real life, we would never want the gear to actually like rub against this non-rotating face. That wouldn't be fun. It would rub a lot. Like the metal would rub away. We don't want to do that. So we can use the offset button here, and we can tell it how far away we want that motor pinion to be from that face. So if I type in something like 0.25, it went backwards, so I'm going to go add a negative sign. All right, so now it's a 1/4 inch away from that face on this side, but it's kind of already in that centered spot where we want it. And if I hit check, we now have that pinion where we need it. I can't click and drag it at all. It doesn't rotate, it doesn't do anything. If we did want it to be able to, say we wanted it to be able to rotate, instead of fastened, we could use revolute. And now when I click check, I should be able to click on this and I should be able to spin it around. So basically it let one of the degrees of freedom go. So now it can, I can spin the gear around the shaft. We're not too worried. We're never worried about like the actual shaft being able to revolve on the motor. We don't need it to do that. In our 3D model, it's not super important. But you can change to different types of mates really easily, depending on what you want it to be able to do. So if you want it to be able to, say slide, I could change it to a slider mate, and then I should be able to have this slide back and forth. I can undo that. Okay, so that's the rough concept of how assemblies and MKCAD let us insert things really simply, and then we can just basically combine them together for stuff that we don't have to create ourselves. Basically, almost any purchase part, MKCAD will probably have some version of it. If they don't, there's oftentimes a download that you can get from the manufacturer, so you can import it and make it easy to assemble, so we're not always getting something. Sometimes that doesn't always work. Sometimes it's a part that's not commonly used, and the vendor may not have a CAD model already, so sometimes we do have to CAD our own parts. But when we don't have to, if it already exists, it's almost always easier to grab the part that already exists. Okay. The next thing on this list that's super useful are these things called feature scripts. Feature scripts are one of the most powerful things in OnShape. So feature scripts, sometimes people call them like custom features. They basically let anyone program OnShape to be able to do things super quickly for us. So any sort of repetitive task that you'd have to do, you can actually write code to let OnShape basically make it just a single button. And there's a couple people in the FRC community, Julia being the one who's done like the most work on it. There's a few others, and there's some other ones that aren't necessarily FRC specific that are also super useful that we'll add to OnShape for us. That let us take a lot of little detail work and make things way, way, way faster. Okay, so to install feature scripts, they are actually super easy to install. We can click on like Julia's feature scripts, this button right here. We also have them in this document that linked in our Discord. The direct links to some of these are here. So like the Julia's ones is direct linked already there. If you don't want to pull them from OnShape for FRC. And they also kind of, there's some pictures that show you sort of what they do, and there's some how-to guides for some of the individual feature scripts that exist. So if we haven't gone over one and you want to know kind of how it works, some of that information is there. When you come into this is really intimidating. You never really have to look at the code. Don't be intimidated by this. I don't understand what's happening here either. I haven't learned how to write any of these custom features. Do not be intimidated by like the first page you see. Anytime you open up like any OnShape document, a lot of times we're kind of already buried deep into some folder. So one of the first things you can do is you can come down to the bottom left and hit this home, and it'll bring up like all the tabs, and you can figure out where you actually like want to be. So for a lot of the feature scripts, they'll have a PDF file as the first tab that you can read through, and they'll kind of tell you some more of the information about things. And then you can start figuring out from the folders kind of what everything does. For right now, we don't need to dig through any of this. All we care about, since all we're doing is trying to add the feature scripts to your OnShape, is we're going to click this custom features button, and it's going to pull up the list of all the different custom features that are in here. And we're just going to click on them, and it's going to have this custom feature 3D printed was added to your toolbar. So you're just going to do this for all of them. Let me double check it doesn't like add them twice or something for mine. I don't think it does. Part Studio. No, they're all the same ones. Okay. So I've already added them, but it doesn't seem like it's a problem if I do it again. So you basically just click through every one of these, and it'll give you that little message saying they've all been added. And pretty much all of these are potentially useful. You'll use some way more than others, but having them already added is convenient. It doesn't really take up that much room to have them all added for you. So just go all the way down. Okay, so once all of those are added, there are others too. So I just went through the ones that Julia made, and those are the ones that she all keeps in there. There's another person, Alex, who makes some feature scripts as well that can be useful. There's some specific ones that are just generic to OnShape, not necessarily people who are doing FRC made. So Lighten is one of them. So it does a lot of custom cutouts and things already for you. And there's a guide on it. Two that we'll probably use pretty heavily are laser joint and T-slot, because it makes some parts that we can use on the laser cutter very convenient. This used to take 2, 3, 4, 5 times as long doing this by hand in SolidWorks, and we can do it really quickly with OnShape, and we'll look at an example of that a little bit later. There's a lot more that I haven't even learned or played with yet that we're still figuring out, but they're very, very handy. Julia is definitely the first ones to get installed, but if you come back through this document and add them all, it doesn't do more than just like make that list a little bit longer. So it's not a big deal. Okay, so all right, so anywhere in your OnShape, if you've already been added to the team, you can do it in general if you want, but we'll just make a lot of them that people can see. This is not going to be anything we use later. Okay, so in your, you can just go ahead and do it in your My OnShape, wherever. We're going to make a new document. So as long as you're at like kind of your OnShape home, you can create a new document. We're going to make a quick Swerve platform. So if you want to call it Swerve Drive, something like that, Swerve Drive Test, whatever you want to call it. And when you make a new document, it starts you off with a part studio and an assembly already. They're both blank. We're going to use a couple of the feature scripts that Julia made to very quickly make a frame. And then we're going to use MKCad to add in the Swerve modules pretty quickly. So first, I'm going to come up and I'm going to use the view cube over in the top right to select the top. And so it kind of switches the way we're looking at the world. And I'm going to make a new sketch. So I can either click this sketch button up here, or I can hit Shift S. And I'm going to select the top plane. And so now I have this sketch. I also have all these planes in view. So you can either come over here and click the eyeball on all of them if you want. You can also hit the P key to hide show planes, so it'll just hide them, take them all away. What I want to do now is I want to have four. Basically, I'm going to draw rectangles because we're going to use the feature scripts to kind of generate our rectangle tubes for us. So we're going to make 1x1 tubes that act like either VersaFrame, which is stuff you can get from Vex that already have holes in it, or maybe we took a regular 1x1 and we drilled our own holes into it. But we're going to use the feature scripts to do all of that for us. So we're not sitting there having to CAD and like sketch out every single circle and make the tubes or anything. It'll kind of do a lot of this for us really quickly. So there's a few different ways to do it. The way I would start this, because I want the center of my robot to be the origin, I'm going to make a center point circle, or a center point rectangle, excuse me. And so then I'm going to click on the origin. So this is right in the middle of our universe again, right? That's that origin point. And I'm just going to sketch it out. It doesn't really matter how big it is in the moment because we're going to add dimensions to it. So the D on your keyboard lets it flip over to dimension. There's also a button up here that is a dimension. So once you click on that, you can drag this over. We're going to make this 28. And we're going to do that again up here. So we have two. So every single side of this rectangle is 28. Once you're finished using a tool, a lot of times you can just hit the escape key and it'll get off of it. So right now it's still in dimension, so I can still like click and dimension more things, but I don't want to, so I'm going to click escape on my keyboard. And now I have my regular cursor back. I am going to select all four of those lines. So you could go through and you could click on each individual one of them. But it's a little bit easier if you just click and drag. It'll generate a blue box and you can select all of them. The blue box is if you click from left to right when you start dragging your square, you'll get a blue rectangle, and it won't select anything unless you include the whole entity. So if I only want to select like the line on the left side, I can just get it that way. If I go the other way, if I click from the right to the left, I'm going to get an orange box, and the orange box will select anything that's even partially in my box. So if I let go right now, it'll select those two lines that even partially intersect. So I want all of them, so I'm just going to click and drag across all of them. And I'm going to change these to construction geometry, which there's a button up here. Anytime you hover over stuff, it'll tell you what it does, which is convenient. Like it'll give you a little description. So if you forget about something, you can just hover over and it'll like read it out. It also tells you what the keyboard shortcut is for some of the stuff. So here it's Q. So if I hit Q on my keyboard, it flips all of these to dashed lines. Okay, so once you have kind of this 28 by 28 rectangle, it's been construction geometried. We can start drawing basically what the tubes look like from like the top of the robot looking down. So we have to kind of decide what our corners are going to look like. The way I did it before was I drew these two the full length like this, and then I drew ones that kind of connect to them like this. So that works, but none of them have quite the right dimensions. And there's a few different ways we can fix that. So I want to use the dimension tool again, right? I want to set something to here. These are going to be 1 inch wide tubes. So I can set that to 1. And then I can hit escape again to get out of my dimension, because I'm just going to select. Sometimes it gets a little odd to select everything. So I'm going to select here. I'm going to zoom in again and select here, because I want these to be equal, right? I want them both to be 1. I could go in and dimension all of them to be 1, and I could have a bunch of 1s everywhere, but maybe at some point I want to change them. If I set these to be equal and they only have like that 1 dimension driving it, it ends up being a little more convenient later on. So to set things to be equal, this whole drop-down list here is all of our different sketch constraints. So there's different ways that I can tell how these two lines are related. And one of them is equal. It also has the shortcut E, so you can just type E instead of having to come to this menu. I can go ahead and just click equal, and it moved this one over to where it's 1 inch wide as well. Our top and bottom tubes don't have that yet, so I'm going to come down here and do the same thing, except it's a little trickier because they're drawn on top of that construction line we already had, and it's not letting me directly select it. So if you ever have two lines kind of on top of each other in OnShape, you can right click and hit select other, and it'll let you select a different line. So say I want that line, I'm going to grab that line again because we know it's the right length, and I'm going to do the same thing up here. I'm going to select other and this line. So we should have those 3 lines connected, and then we already learned that equals is E on the keyboard, so I can either click the button up here or I can click E. And now all of my rectangles are 1 inch wide. Since I already drew them on those corners that existed, I know that these 2 long ones are 28 inches long, and the 2 short ones, since they each have an inch taken off on both sides, these should end up being 26 inches. And everything's defined, so everything turned black, which means I can't drag it or move it anywhere, so it's fully defined. They all have been dimensioned. Nothing's going to let me drag it and move it, which is what you want. Fully defined sketches are the nicest. It means we basically told OnShape all of the information that we know that that's going to be the accurate way to create that part. Okay, so once we kind of have this sketch, this is the only bit of the sketch we need before we can start using Featurescripts, because Featurescripts lets us do some really powerful stuff that's going to go through and kind of make all of these tubes for us. So I can go ahead and hit check, and my sketch is done. I just have these like sketch regions, and this is our Featurescript menu right here on the top right. And we're going to use a feature script first called Extrude Individual. And that lets us extrude multiple sketch regions into a part, so into multiple parts. So if I didn't use that feature script, so if I did it manually real fast, I can show you what we would do. So I could click on this, I could tell it to be 1, but if I clicked on a second one, it wouldn't make it two different tubes. It would make it like one solid thing, and that's not what we want. We want these to be two separate parts inside of our part studio. So if I click check right now, we get like this L, and it's a single part, but that's not actually what we want. So I'm going to undo that, and I'm going to use the feature script, and it's going to do what we want. So I'm going to use Extrude Individual. And so now I get to, it asks me to select the sketch regions that I want to basically become their own parts. So I'm going to select each of these 4 rectangles. And so those 4 rectangles now, when I click check, are going to show up as parts 1 through 4 instead of all showing up as part 1. So once you do that, we now have, you can see that there's a line there, right? So each one of these, I can go through and see, okay, I have 4 different parts. Oops, hit the wrong button. I have 4 different parts that are all kind of, just rectangular bars right now. So they're not tubes, they're like solid. This doesn't really look like any sort of material or anything yet. So from there, we use the next feature script we're going to use, since we already have we have like what's going to be our tubes. We use like one of the most powerful things that they created as a feature script called tube converter. So tube converter is going to take these rectangular prism, square prism shapes and turn them into tubes for us and put the whole patterns in for us. So I'm going to go ahead and click tube converter. We're going to tell it which bodies to convert. So we're going to select all 4 of our bodies. We're going to convert all 4 of our bodies, and that gives us our, they basically make them into tubes, and they put a whole pattern running all the way down for us every 1 inch. We can kind of determine some of the whole patterns based on all of these settings over here. We don't need to worry about it too much for this project, but depending on what you're doing, you may want to change some of the settings. We'll actually need to come back in a second because the hole offsets are a little bit weird. Because you can see, like, it kind of has to make a choice. On the 1 inch tubes, they're offset every ½ inch on the different faces. So it would have to like decide whether we wanted this hole here, or do we want this like whole tube to be kind of rotated. Later on, I think we do want to rotate it, but I'm going to do it without it first, then we can come back to it. So if I hit check, it's now taken just those plain kind of simple boxes and made these very much closer to actual robot parts, basically ready to go for us in a few clicks, instead of having to like draw this circle and then use like the linear pattern tool to pattern it all the way down and figure out how many holes you need. Then you have to do the same thing on the other side, and it's just a lot more work if we didn't have that feature script kind of ready to go for us that generates the tubes that quickly. Okay, so once we have that, this frame is basically all we really need for what we're going to do today. And we're going to move it over into the assembly. So similar to what we did with the motor earlier, we're just going to insert. And so instead of going to other documents like we did with the Falcon to pull the MKCad, right now we're going to pull our part studio first. So we can click the entire part studio if we want. We could also click individual tubes if we wanted to. But since we already laid everything out in the part studio and everything's kind of in the spots that we want it to be, we can take advantage of that by just inserting it as a whole part. Again, if we like leave it and we don't click off, it'll insert it right at the origin for us. And we can go ahead and click the check mark. And now we have this kind of frame in our assembly universe ready to go, and then we can add things to it pretty easily. When we insert our first part, remember we have to fix something. So if we don't, I can just like click and drag and I can move this around. Control Z does, so it'll put it back. But we can't just fix a single thing because it inserts all 4 of these parts as a as their own part. So one of the things we can do is we can click and drag and select all of them, or you could select them all over for the menu here, however you want to do it. And we can tell them to group these parts. So once they're grouped, they won't move with relation to each other. So we can move the whole thing, but they'll all stay kind of where we want them, where they were kind of put from the part studio. So this is a really easy way to keep a part studio together after you've inserted it into an assembly. So I click that group button and then hit the green check mark because I already have them selected. And then if I move one of them now, they all move. I'm going to Control Z again because I did want it back where it started. And I'm going to right click on one of the parts and click Fix. So once that's fixed, just like before, I can't move any of these since they're grouped to the one fixed part. Okay, the last thing we're going to do is we're going to insert Swerve modules into the corners here. So using the MKCad part library like we did with like this individual Falcon, you can also insert entire assemblies sometimes. So I come over to MKCad because we have that label. We can find MKCad Swerve. And the one we want is an assembly. And it's this SDS MK3 Swerve module. It has some options, so you can choose different. There's different like motors you could select. You can have it with or without motor spacers. We're gonna go and select motor spacers and click generate. And now maybe it takes a little second. All right. So then once it has that, I can kind of just place this in our universe somewhere. It doesn't need to be on the origin because we're going to move it. We're going to mate it to these rails in just a second. So we have one, and we can figure out how we're going to insert it. So I'm going to kind of get it roughly in the right spot. It's never exactly right until we do the mating. I'm just going to make sure we get the kind of the correct holes. All right, so the rough idea here is that this hole is going to be the one that we're going to like put it through, right? That fits about where it's supposed to be, but we do see there is a bit of a problem. The holes over on this side don't line up, but we'll go back and fix that in just a second. So if we mate like we did before, so I can either come up here and click the fastened mate. I can also just click M on my keyboard for the mate shortcut. And then you're going to kind of click the two parts of the circle that you want to basically touch together. So I want the bottom of this circle, and it shows that kind of mate connector right there. I'm going to rotate over with my right mouse button to be able to rotate. And then I'm going to click right here for the top of this circle. And that kind of makes them bolted together. I can click check, and then I can click X, I'm done mating. And that's all we really have to do to mate this entire thing. So this thing can't rotate, it can't do anything because it was already where we wanted it. If for some reason something changes a little bit, you can come in here and like edit the mate. You can choose which way you want it to like rotate if for some reason it wasn't right. If it like sometimes it'll mate a little bit out of orientation and you need to rotate it around. Sometimes you need to get it like flipped, but that would be weird here. It would like flip the whole thing over. That's definitely not what we want. So a lot of times you're just clicking like this button and this rotate button until you get it to the view that you want it to actually be at, because there's a few different options and it doesn't always know which one you want. Okay, the last thing before we have people do it themselves, we're going to go fix this side tube to get the holes in the right spot. So these 4 holes are all good, and we'd be able to put fasteners through them. These holes are not, so we're going to come back to our part studio. We're going to edit our tube converter, and we're going to not have, what are we going to do? We're going to not have this part and this part. So we're going to only use tube converter on these 2 outsides, and then we're going to use tube converter again, but we're just going to change some of the settings on these two. So now I have those selected, and instead of centered on tube, I'm going to let it do auto offset, and I think that solves it. Yeah, so that I think moved it to basically be like ½ inch from this side, so these holes kind of line up, they're the same distance away. And I can show you how to do that again in a second when we go through it all together. And now if I come back, without having to, I haven't changed anything. I didn't have to like make anything. Oh, it did actually. Why did it do something? It got mad at me now. You decided that wasn't correct. That's weird. Okay, well we're gonna re-add that in because it decided when I deleted that tube connector that it didn't like it. But that's quick to change, so we're okay. Okay, so that exists, and the final thing is we need to have 3 more of these. So the way Swerve modules works, you basically have a wheel in every corner, and so we need to add another one. So we could go in and we could copy and paste this ourselves, and we could add a new mate connector at each one. That would work. The other thing we can do is we can take advantage of rotational symmetry, since this is like the center point of the whole robot, and we can add one. We can use a circle pattern to basically add the 3 more. To do that, there's a button called Assembly Circular Pattern. It needs some sort of axis to pattern on, and the origin itself doesn't work for that. So we're going to insert our own mate connector with this button right here to give us that sort of axis. So I'm just going to click on the origin, and it's going to have this little mate connector, and it has that axis right there through the center. And then when I click Assembly Circular Pattern, I can tell it I want to pattern our Swerve modules. So I can click on the little module over here. It highlights all of it. And then I'm going to click on this mate connector. And now it knows the rotation pattern. And I can tell it how many I want. I can tell it where they are. So right now it's only doing 2 of them every 360 degrees. I could tell it I want 6 of them, which would be confusing. Like that doesn't look right. So I'm going to make it 4 of them because that's what I do want. Maybe if it'll generate the preview. There it goes. So the 4 of them now get inserted into the corners, and they're basically ready to go. So yeah, so you can do things really fast, right? We didn't have to model very much. We basically sketched, 5 rectangles, and we were able to do all of this from that, just with other buttons and things. Okay, so this is basically where ideally I'd want everyone to get. So I'm going to go ahead and stop the recording, and then we can work with everybody to get there.